morning, everybody. We are starting with Chapter 4, Presentation of Data. There are three broad forms of presentation: textual presentation, tabular presentation, and diagrammatic presentation. Textual presentation involves presentation by using text in the form of words, messages, alphabets, etc. Tabular presentation is a form where tables are constructed in order to represent raw data. The tables can be presented on the four bases. Number one, qualitative, which means characteristics or attributes which cannot be measured in quantitative terms. Second, quantitative, which means characteristics or measures which are measurable in quantities. Third, temporal, wherein the table is constructed on the basis of time, which can be in days, years, weeks, months, hours, etc. And fourth, spatial, wherein the table is constructed on the basis of location, area, geography, etc. These are the four ways in which the data can be presented in a tabular form. Diagrammatic presentation includes three types of diagrams: geometric diagram, frequency diagrams, and arithmetic line graph. Let's start with the tabular presentation. The table shown on the screen shows that literacy in India by gender in percent has been presented in the form of table. You can see that this table is classified on the basis of gender, and gender is a quality. So you call this presentation as qualitative presentation. Next is quantitative presentation, wherein you can see that the marks of students in economics are presented through a table. In this table, quantities are measured, and on the basis of quantities, that is marks, the table has been presented. This type of presentation is called quantitative presentation. The third one, temporal presentation. As you can see, students, this table is constructed on the basis of years, which is time. So a presentation which is based on time in years or days or months, etc., that type of presentation is called temporal presentation. The last one, spatial presentation. As you can see that here the table is constructed on the basis of states: Kerala, Madhya Pradesh, Bihar, Rajasthan. This belongs to a location, and classification when done on the basis of location or geography is called spatial classification, and the presentation of table is called a spatial presentation. There is a table shown on the screen wherein the parts of a table are mentioned. Words written in boxes represent the parts of a table. On the very top, we have the table number, which gives a number to every table. This number is used for reference purposes. Then you have a title of the table, which provides information about the contents of the table. Below title, we can see in the box it's written column headings or captions. Students, these are basically the headings which we give to all the columns. Other name for column headings is captions. On the extreme left hand side of the table, you can see in box row headings, or the other name is stubs. So if I talk about this particular table, the row headings are all, urban and rural, and the column headings are location, gender, workers, non-worker, total. On the right hand side of the table above the table, we write units. The data which is presented in the form of units, the units are written on the top. Extreme right hand side of the table represents the body of the table. The data which is presented inside the table represents the body. Under the table, we write the source note, which indicates the source from where the data has been collected. And lastly, there is a footnote at the end which provides any additional information that cannot be provided through the table. So there are 8 parts of a table, as you can go through: table number, title, captions or column headings, stubs or row headings, body of the table, unit of measurement, source, and note, also called footnote. We come now to the diagrammatic presentation of data. The first type of diagrammatic presentation are geometric diagrams, which are further subdivided into bar diagram and a pie diagram. And bar diagrams are further divided into 3 categories: single bar diagram, multiple bar diagram, and a component bar diagram. Let's start with the bar diagram. So here, students, it's a simple bar diagram presented to you on the screen, where you can see green color rectangular bars. As you can see, the words written in bold, equi-spaced and equi-width rectangular bars for each class or category of data. Equi-spaced means that the space between 2 bars is always equal. And equi-width means that the width of every bar is also equal. The height of the bar reads the magnitude of data, also called frequency. A simple bar chart is shown like this, where there is proper space between 2 bars and the width of every bar is same. Here you can see a multiple bar diagram. The difference here is that in this multiple bar chart, 2 variables belonging to a particular year are represented on the same chart. As you can see, for the year 1991, there are 2 rectangular bars, one in yellow and one in green. The yellow bar indicates imports and the green bar indicates exports. Likewise, you have 2 bars each for all the years. When we show data like this, it's called a multiple bar diagram. Component bar diagram is again a bar diagram where we draw single bars. The space between bars is same. However, we divide the single bar into different components. As you can see, every rectangular bar is divided into 3 parts. One in blue, other in purple, and the other in orange. Blue color denotes production of oats, purple denotes production of barley, and orange denotes production of wheat. So a component bar chart is a diagram which is useful in comparing the size of different component parts. The fourth type of geometric diagram is a pie diagram. As you can see, it's basically a circle which is divided into its components. The circle is divided into as many parts as are there in the components by drawing straight lines from the center to the circumference. Every circle is divided into 100 equal parts and every part is of 3.6 degrees each. So whatever are the components, we plot it on the pie chart or a pie diagram by converting the values into proportionate angles. We are now starting with the second category of diagrammatic presentation of data, which are frequency diagrams. There are 4 types: histogram, frequency polygon, frequency curve, and ogive. Starting with histogram, students, it's a 2-dimensional diagram where on x-axis class boundaries or class limits are shown and on y-axis the class frequency is depicted. All the rectangles are adjacent to each other, which is a basic difference between a bar chart and a histogram. There is no space between the rectangles. Point to be noted here is that histogram construction gives the value of mode of the frequency distribution. As you can see here, a bar chart and a histogram both are made out of rectangles. However, there are no gaps in a histogram and there are equispaced gaps in a bar chart. This is an example of histogram where the midpoints are marked on the x-axis while the frequencies or the number of students are marked on the y-axis. Whichever rectangle has the highest length, the edges of the rectangles are joined with the next and the previous rectangle, and where the two lines intersect, when it brings down to the x-axis, the point P is the mode of this data. The second type of frequency diagram is a frequency polygon. This is also derived from the histogram itself by joining the midpoints of the top of the consecutive rectangles of histogram. The total area under the curve represents the total frequency of the distribution. As you can see, the midpoints of all the rectangles on the top side are pointed and then joined using straight lines. The first and the end points are all extended towards the x-axis in order to make the polygon start from x-axis. So this is basically collection of all the points which are the midpoints of all rectangles of a histogram. The third is a frequency curve. It's basically a smooth freehand curve which passes through all the points of frequency polygon. It might happen that all the points are not on the frequency curve, but a curve is almost closely passing by a frequency polygon. So, a frequency polygon, when drawn using smooth freehand like a curve, is called a frequency curve. So here, as you can see, the dotted line is a very smooth curve which is called the frequency curve. The fourth are ogives, or also called cumulative frequency curve. Since the name is cumulative frequency curve, we are plotting cumulative frequencies on the y-axis. There are two types of ogives, more than ogive and less than ogive. Point to be noted here is that the intersection of less than ogive and a more than ogive gives the value of median of a distribution. As you can see here, the red curve is the less than ogive and the green curve is the more than ogive. Less than curve always slopes upwards and a more than curve always slopes downwards. On the x-axis we show classes and on the y-axis we show cumulative frequency. This is an example of a less than ogive where the points are plotted on the graph and then they are joined using freehand. We get a less than ogive from this. Another example of more than ogive, again the points are plotted using the length and the cumulative frequencies, and the points when joined together gives you a more than ogive. The last type of diagrammatic diagrammatic presentation of data is arithmetic line graph. This is also called a time series graph. From the name itself, it's getting very clear that in our distribution, if the basis of classification is time, then a time series graph is drawn. As you can see, on the x-axis we have years, and on the y-axis we have two variables, export and import. By plotting the points on the graph, we get two lines which is called the arithmetic line graph. The blue line indicates imports for different years and red line indicates exports for different years. That's it. Thank you.